All right, let's go ahead and look at some complex numbers. So we have this imaginary unit I, and I is essentially equal to the square root of -1, or I squared is equal to -1. A complex number is defined as a plus bi, where a is the real portion, and then the b is the imaginary part. So let's go ahead and look at what the meaning of the square root of -a is. Essentially what we have is -a, and this could be also defined as -1 times a, and we can further break this apart into the square root of -1 times the square root of a, and we know from up above that the square root of -1 is equal to I. So we can further reduce this and say I and then the square root of a. Okay, so let's go ahead and look at some examples here. We want to write the square root of a as I and then the square root of a. So our first example, we have the square root of -81. So first thing we can do, again, we can go ahead and break this apart. This will be the square root of -1 times 81, which is also equal to the square root of -1 times the square root of 81. And we know again that the square root of -1 is equal to I, so we can write I, and the square root of 81 is 9, so we can go ahead and write 9. And a further way that we can reduce this is just saying 9i. Okay, so for example number 2, again, let's break this apart. Square root of -1 times 55, which is also equal to the square root of -1 times the square root of 55. Again, we know that the square root of -1 is equal to I, so we can say I, and then we cannot further reduce the square root of 55, so we can just leave it as the square root of 55. Okay, let's look at our third example here. Again, break it apart. Square root of -1 times 98. This is equal to the square root of -1 times the square root of 98, equal to I. And then let's go ahead and further break down the square root of 98. So, square root of 98, we can say 49 times 2, and then further break this down into 7 times 7, and we have a pair here. So to further reduce this, what we can say, this is equal to 7i, and then the square root of 2. All right, so let's go ahead and look at finding products and quotients involving the square root of -a. So we have the square root of -21 times the square root of -21. Let's go ahead and break this down, similar to the examples we just saw. So we already know, breaking this down, we have the square root of -1 times 21. So let's just go ahead and further reduce this. I and 21 times, and then I, and then the square root of 21. We can say I times I, which would be I squared. And then we also have square root of 21 times square root of 21. So in that case, we can go ahead and do square root of 21 squared. And then again, if we remember, this I squared is equal to -1. So we can go ahead and say -1. And then these will go ahead and cancel out because it's the square root, and then that's raised to the second power. So we have -1 times 21, which is just equal to -21. Okay. So for our second example, let's go ahead and reduce it. I and then square root of 5 times I square root of 30. Again, I squared times, and then we'll have a 5 times 30. and then I squared, and then we'll have square root of 150 because it's 5 times 30. And we can go ahead and further break down the square root of 150. So this will give us a 50 and a 3, a 25 and a 2, and then finally a 5 and a 5. So we'll go ahead and reduce this down to I squared, 5, and then the square root of 3 times 2, which is 6. So this will be -5, and then square root of 6. We have 2 more examples here. So looking at the square root of -42 divided by the square root of -3. Let's go ahead and dive into this one. Again, we know from previous examples this would be I and then the square root of 42, and then this would be I square root of 3. Now one thing that we can do here is go ahead and cancel out our i's. So that leaves us with the square root of 42 divided by the square root of 3. And if we want to further reduce this, this will give us the square root of 14. Now looking at our last example here, square root of -63 divided by 21. This will give us I and then square root of 63 divided by the square root of 21. And if we want to further break this one down, we can go ahead and look at this, and we'll have I and then square root of 63 divided by 21, which will give us 3 underneath the square root, so we can say I and square root of 3. Okay, so let's go ahead and look at simplifying a quotient involving the square root of -a. For our first example, what we want to do is go ahead and write 15 minus the square root of -75 divided by 5, and we want this in standard form. So our standard form, let's go ahead and get started. We can go ahead and say 15 minus, and then further break this -75 down. So this will be -25 times a 3 divided by 5. And again, we have a negative underneath our square root. So let's go ahead and bring that I out. This will give us 15 minus I, and then the square root of 15 and 3. We can go ahead and take a 5 out and leave a 3. So we'll say 5 and 3, all divided by 5. A few more steps here to simplify. What we'll have left, we can take our 15 and divide it by the 5, and then finally we can take our other portion and divide it by 5. So that gives us a 15 divided by 5 minus 5i square root of 3 divided by 5. And we can cancel some 5s out here. So we have a 5 here and a 15 here. 15 divided by 5 is just going to give us 3. And then we'll have our 5s cancel out here, which will give us I and the square root of 3. And this will be in the standard form that we want it in. All right, so addition and subtraction of complex numbers. For complex numbers a plus bi and c plus di, we have these properties here. So a plus bi plus c plus di is going to be equal to a plus c plus b plus d, and then outside of our parentheses is going to be our I, and then a plus bi minus c plus di is going to be equal to a minus c plus b minus d, and then again our I outside of our parentheses. So using these, let's go ahead and look at some examples here. So for our first example, what we want to go ahead and do let's take our 4 and our negative 5. 4 plus negative 5. And then let's go ahead and take our i's here. So we have 5i and we have 8i. We're going to do plus negative 5 plus 8 and then I. And I'm getting this from, again, our properties up here. We see that we have a plus in between, so that's going to be this first one. And then our second one, we see that we have a minus there. So that's going to be our second equation up ahead. So this will give us our negative 10 and our 5. Simplifying, we will have a negative 10 minus 5. And then we'll have plus 7 and then minus 3. And then I. This will give us negative 15 and then plus 10i. Okay. So looking at the multiplication of complex numbers, for complex numbers a plus bi and c plus di, we have a plus bi and then c plus di, and we're going to multiply those, leaving us with ac minus bd plus ad plus bc, and then outside of our parentheses we'll have the I. And when we reduce this, it'll look something like this. So let's go ahead and apply that. First things first, let's go ahead and multiply our 5 times the 2, which gets us a 10. Then the 5 times the negative 7i, which will give us a negative 35i. Now we'll do the 3i times 2, which will give us plus 6i. And then last we'll do the 3i times the negative 7i, which will give us a minus 21i, and don't forget that it's squared. So let's go ahead and further reduce this. We'll have 10 minus 29i minus 21 times, and then if you recall, I squared is equal to negative 1, so we can go ahead and put that in there. And then our result should be 10 minus 29i plus 21, which is equal to 3i minus 29i. All right, example 2. 4 minus 5i squared is really just the same thing as 4 minus 5i times 4 minus 5i. So again, we'll do the same thing that we did in example 1. 4 times 4, that should give us 16. 4 times negative 5i should give us negative 20i. Negative 5 times 4, again, another negative 20i. And then finally, we'll have the negative 5i times negative 5i, which will give us plus 25i squared. Let's go ahead and simplify. We'll have 16 minus 40i, and then plus 25. And then again, remember the I squared is equal to negative 1. So this will give us 16 minus 40i, and then minus 25, which is going to be equal to negative 9. Negative 9 minus 40i. All right, last example here. We have 9 minus 8i, and then we have 9 plus 8i. So let's go ahead and do it. 9 times 9 is going to give us 81. 9 times 8i will give us plus 72i. And then negative 8 times 9i, or negative 8i times 9 will give us minus 72i. And then last thing will be negative 8i times positive 8i, which will give us negative 64i squared. And if you see, we have a positive 72i and a negative 72i. These will cancel out, leaving us with 81 minus 64i squared. Don't forget to substitute that as a negative 1. So that leaves us with 81 plus 64, which is equal to 145. Okay, let's take a look at the property of complex conjugates. So let's just go through some examples here. We have 5 minus 5i divided by 3 plus I. We want to go ahead and try to simplify this as much as we can. So in order to get the 3 plus I out of the bottom, or to simplify it, let's go ahead and multiply by 3 minus I. Okay, so 3 minus I, if we multiply that on the bottom and the top, what we'll be left with is 5 minus 5i, and then 3 minus I, and then our bottom is going to turn into 9 minus I squared. This is similar to one of the properties that we looked at previously. So now let's go ahead and further simplify as much as we can. We'll go ahead and multiply out the top, which will give us 5 times 3, so 15. 5 times negative I, which will give us negative 5i, and then negative 5 times 3, or negative 5i times 3, which will give us negative 15i, and then finally negative 5i times negative I will give us positive 5i squared, all divided by 9 minus I squared. Okay, so this will be 10 minus 20i divided by, and then 9 minus I squared would be minus a negative 1, so this will turn into a positive 1. And the final simplification here, 10 minus 20i divided by 10 will give us 1 minus 2i. Okay, looking at our second example up here, 15 divided by negative I. Let's go ahead and multiply by I on both the top and the bottom. This will be 15i divided by negative I squared. And then we'll still have a 15i on the top. Now we have a negative, and then I squared is equal to a negative 1, so it's a negative negative 1, which is really just equal to 15i. Alright, our next topic is going to be simplifying powers of I. So if we're looking at I to the first power, that's just 1. And then if you recall previously, I squared is equal to negative 1. Well, how about the other powers? Well, we know that I to the third is equal to I squared times I. And we know that I squared is equal to negative 1. So let's go ahead, negative 1 times I, so that's just going to be equal to negative I. Let's do the same thing for I to the fourth. I to the fourth, we know that that's just I squared raised to the second power, and if we know that I squared is equal to negative 1, that's negative 1 to the second, or just 1. And let's look at I to the fifth. I to the fifth, we can already use what we've created here, so we know that I to the fifth is really just I to the fourth times I. And if we said that I to the fourth was equal to 1, we can say 1 times I, or just equal to I. And I to the sixth power, again, we can go ahead and use what we've already learned. So we know that I to the fifth is equal to I, so we can say I to the 5th times I is equal to I times I, which is equal to I squared. And again, I squared is equal to -1. All right, and then 7 and 8, we can go ahead and do those as well. So this will be I to the 6th times I, and if I to the 6th was -1, we have -1 times I. So this will just give us -I. And last but not least, we'll do I to the 8th. Let's just say, for example, I to the 4th times I to the 4th. You could also do I to the 7th if you wanted to simplify it. But for our case, let's just say I to the 4th, which was 1. So 1 times 1, or just 1. All right. So using some real numbers here, our first example, let's go ahead and try to simplify I to the 33rd. So I to the 33rd, let's see what we can break this down with. For our case, let's just say I to the 8th times 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 I. If we look up top again, we simplified I to the 8th as just equal to 1. So plugging that in, we have 1 times 1 times 1 times 1 times I. So that's just 1 times 1 times 1 times 1 times I, which is just equal to I. Okay, how about if we throw in a negative here? Well, I to the -14 can be simplified like this. We could just say that is 1 divided by I to the 14, and then go from there. So for this one, let's just say I to the 4th times I to the 4th, and then we'll do I to the 4th and then I to the 2nd. And this will give us I to the 4th. Let's see what that was. That was 1. So we'll have 1 times 1 times 1. And then I squared, if you remember, that was -1. So simplifying this is just going to be equal to 1 divided by -1, or -1.